Good morning, friends. Let's implement amendment of orders using PriorityQueue. So we have got this interface before, order book I, where we have implemented adding an order, matching an order, cancellation of order in the previous video. And in this video, we will do amendment of orders, where we have got three methods here, as you can see. One is for amendment only on quantity. The second one is only for price. And the third one is on both quantity and price. And then the main parameter that we pass is the order ID first, for which we want to make the amendments. So let's go with all this, like any one of three. I will go with the third one, which is amendment on both quantity and price. Use this Control B and then take the interface for PriorityQueue. So this is what we have. I think if you see all the other implementations, whether it's for only for quantity or price or for both of them, they're having the same set of like methods, which is remove and add order. So let's go through it in details. So for say amendment of order, we provide the order ID, and then we have got the new quantity and price. So first of all, we'll do the preconditions that we will first of all check whether that order is present or not in our cache. If you remember, we are maintaining this order cache where we are storing the order ID as key and the actual order as our value. So this, first of all, if you want to amend anything, we have to see whether it's present in the order is present there in our cache or not. So this is the first condition. And the second condition is that the basic, that the new quantity cannot be less than 1, and the price can also not be negative. So these two conditions we check first. And after that, if it's all passes, then we will actually fetch the order ID. It means that our order is present in our cache. And then we set, remember that once we set once we get the order from our cache, after that we have to set the new quantity and the new price which has been provided to us in our arguments here. After that, we'll use the same approach that we discussed before for linked list implementation as well, that we will cancel the original order first, and then add this new amended order. You see that we have amended the quantity and price. We will add it back. So this is what it is doing. It will first of all remove the order from our cache and our priority queue list, and after that it will add it back. And as we have implemented it before, the removal is same as cancelling an order, which took O and of log time. And for adding it back, while adding, just remember that we are adding it back to our priority queue, and priority queue has got like a price and time priority, but all this can be done in O, log, and time. So if we both do remove and addition, we see that for removal is O(n), and for addition is log n. So the worst time complexity for this whole amendment should be O of n, right? So this is what it would be for all our three implementations for amendment using PriorityQueue. Again, if you go back to the remove order, just going a little bit into details. For removal, it's same as cancellation. It will get the order ID first from the cache, then checking on the side, it will remove it accordingly. And for removal, on a priority queue, we have learned that it always takes O(n) time. So the overall time complexity of removal of order is O(n). And for adding it back, if I go with the implementation, first of all, it will when it adds back to our order list, our priority queue. In that case, first of all, it will try to match it first, because we have got a new price, right? So when the new price is added, it means that there's a possibility of matching as well from the opposite side. That's why it will try to match it first, which is going to take analog. And then after that, it will see that whether it can be added back or not. So all this we have discussed before when we discussed about the adding and matching. So I'll not go into details again. So just to remember that the overall time complexity for amendment of order, when we do, first of all, we do the cancellation, which will take O of n, and when we add it back, it will take log n. So the worst time complexity would be O of n. Okay. And I use the same remove and add order in all the three implementations. If you see for amend order for both quantity and price, it's same. I'm using remove and add order. Similarly, only for price, it's same. We only set the price when we want to change the price in my amend request. And similarly, only for quantity, in the same. We set the quantity and then we call this remove and add order. Now for the test cases, it's quite simple. For all, I've written 3 unit test cases. One's for quantity, one for price, and one for amend quantity and price. So going through one of them would be sufficient for this example. So let's go to our test order amend quantity and price, where we'll try to amend both quantity and price. So first of all, if you have been following the previous videos, first of all, we'll set up our order book. And once the order book is set up, we are trying to place 3 buy orders and 3 sell orders, which would be sitting in the order book. It would look like this. So we'll having, you can see that at the top, these 3. Let me open up this. Okay. If you see the top of this, like 3, these are all 3 sell orders that we will place in our setup method. And similarly, 3 buy orders. With the top of them, this is the top of the order book. For buy, this is the best price available. And this at the bottom of the sell price, this is the best price available for sell, 20.25. So we have discussed about this, so I'll not go into a lot of detail. So once this is done, once we set up this order book, here we are setting it up. So once this order book is set up, let's go back to our test case, which is this one. Now we are going to send a new order, buy order of say 200 at 10, which will be sitting at the bottom of the order book, because the price is 10, right? So in this case, it will be the price is like as compared to the other buy orders, we have got 20.20, 20 and all. So my idea was to send a buy order which cannot be matched. That's why it will be placed here at the bottom of this order ID 6. So here this will be placed with the price of 10. Okay. Once this is done, then we will print order book to show that whatever what are the orders which are there. After that, we will amend order using that amend order method that we have implemented. So I just go to the implementation again. So order list using price. This is what we did discuss, right? So this is what we are going to test here. So once we do the amendment, right? The earlier the quantity was 200, we make it 250, and the price was 10, we make it 20. So this is the amendment on this order that we are going to send. After the amendment, there would be no cross again, because still the price is 20, which is less than and then any type of like sell price available. So that's why there would be no match. Then we print order book to show that our amendment was good. And after that, we do some basic assertions that our whatever the quantity that we have amended, that should be matching. So let's run this test case, and then it would be obvious that what's going on. So I've just run this test case, it's passed. So first of all, the setup method, it will print the current order book. It will be showing 3 buy orders and 3 sell orders. After that, I send a new buy order at 200 at 10. So as expected, because the price is only 10, it would be placed at the bottom of the buy order book here. And it's order ID 7. Now we are going to amend this order with the new quantity from 200 to 250 and price from 10 to 20. Although it's 20, there is no possibility of matching, right? Because we don't have any sell orders available which can be matched. So that's why once this is amended, we again print our order book here. So this is after amendment. As we can see that order book after amendment, we expect that at the bottom of this, our order ID 7 has been amended with the new quantity and price. As you can see that now it's 250 and the price is 20. So our unit test case works as expected. So just to conclude our implementation of for order book matching engine using a PriorityQueue, we can compare that we have used 2 approaches: linked list first and PriorityQueue. And this is all the comparison of all the methods that are available for both of these implementations. As you have just covered amendment of quantity, price, and everything, we can see that for linked list, it was a very poor performance, which was just taking n log n. But using PriorityQueue, it was much improved to ON. Okay. Now for cancellation, it's same. We can see it's ON and ON. For matching, again, PriorityQueue is not as efficient as linked list, which we discussed before. It is taking n log n. But for addition, again, PriorityQueue is much better because it only uses like a priority heap priority methods for adding an order back. So that's why PriorityQueue is better for addition. So now we have seen the best parts of linked list and the best parts of PriorityQueue, but both of them are using only like 1D data structure. In the next video, we will go with what are the limitations using this 1D data structure and how we can improve the overall design, which will our final implementation of our order book matching engine. So see you all in the next video.